Hi, this is Mrs. Ward, and I'm going to go over section 2.2, basic differentiation, rules, and rates of change. So in this section, what you're going to learn how to do is find the derivative of a function using the constant rule, the power rule, the constant multiple rule, the sum and difference rules, and then you're going to find the derivative of sine and cosine functions, as well as use derivatives to find rates of change. And it sounds like a lot, but it's actually much easier than 2.1 using the limit definition to find the tangent line. So let's start with the first example where we are going to find, we are going to use theorem 2.2, which is the constant rule, which asks me what the derivative of a constant is. So if you think about y is equal to 6, that is a graph at y is equal to 6. And if I ask you the slope of that graph, you should tell me that you know the slope is equal to 0. So when I go to find the derivative, remember the derivative means the slope of the line, and so the derivative is also going to be 0. I'm using the same notation, so if they give me y, I'm doing y prime. If they give me f of x, I'm doing f prime x. And the derivative of 0, that's just a horizontal line at 0, so the slope is still going to be 0. And then y is equal to pi. Remember, pi is a number, 3.14. So that derivative is also going to be 0. So when you're asked to find the derivative of constant, it's asking for the slope, and the slope of any constant function is just going to be 0. Okay, the next one, it says the power rule, and this is probably the one that you're going to use the most. The power rule says if you have a function raised to an nth power, to find the derivative, you take whatever that power is and you put it out in front, and then you reduce the power by 1. Simple. So let's go down to the next one where I have y is equal to x to the fourth. In this case, my n is equal to 4. I'm going to bring the 4 down in front. So this will be 4x. Reduce that power by 1. So 4 minus 1 will be 3. My derivative is 4x to the third, which is so much easier than what we've been doing. You don't have to take f of x plus delta x minus f of x all over delta x and take the limit as delta x approaches 0. This does all that for you. If I have a radical, I'm going to rewrite the radical exponent as a fraction. So I'm going to write this as x to 1/3. And then I'm going to do the power rule, remembering that my n now is that 1/3. So I'm going to say f prime x, bringing my power down in front. And then I'm going to take 1/3 minus 1, and I get -2. So -2/3. So 2. And then I don't like the negative exponents, so I'm going to rewrite that as 1 over 3x to the 2/3 power. So looking at the next example, I have 1 over x to the fourth. I'm going to think of that as x to the -4th. And so to find the derivative, my n in this case is going to be -4. So I'm going to bring down that -4x, and then -4 minus 1 will be -5. So my final answer without negative exponents is -4 over x to the 5th. I do not want negative exponents, so you have to take care of the negative exponents if your exponent happens to be negative. But that's not hard, right? That was fairly easy. Now looking at the next one. And this one wants me to find the slope of a graph at a given point. So it gives me one equation. F of x is equal to x to the third. So the first thing I'm going to do to find the slope of the graph is I'm going to find the derivative of this function. So in this case, my n is equal to 3. And then reduce the x to the third, reduce that by 1. So this will be 3x squared. And that's my derivative. To find the derivative of x is equal to 1, I'm going to substitute 1 into the derivative formula. And I'm going to have 3 times 1 squared. And when I do that, I get a slope of 3. When I do for 0, sometimes I just have problems writing. And I'm going to have 3 times 0 squared. And that's going to give me a slope of 0. Then if I do this one, -1, -3 times -1 squared, and that's also going to be 3. And what I did to show you what's going on is I graphed the original function. So I graphed x to the third. And we're all familiar with that graph. This is x to the third. So when I'm at 1, if I were to draw a tangent line right here, it would have a slope of 3. When I'm at 0, if I were to draw a tangent line, it looks like the graph sort of takes a break and it's not increasing anymore, just sort of has like a bump. That slope would be 0. At -1, it's still increasing, so it's going to have a slope of 3. If this derivative is positive, that means your function is increasing. If your derivative is equal to 0, that means you hit like a bump. So I did something like this in this case, or it could be like a parabola, where I hit the top of that parabola, or the bottom of the parabola, depending on how your parabola opens. So that's finding the derivative at a point, or the slope of the graph at a point. Now, number 4 says find the equation of the tangent line. So remember, I need 2 things when I'm finding an equation of a line. I need a point and a slope. So they tell me they want me to find the slope of the equation of the tangent line when x is equal to 3. So the first thing I'm going to do is find the point at 3. In other words, I have the x value. I need to find the y value. So I'm going to just substitute 3 into the original equation. So x, well, I'm going to write 3 squared plus 3 times 3 minus 4, and I get 14. So I have the ordered pair 3, 14. That's the point where the graph, where I want to find the tangent line. That point is on the tangent line graph. Now I need to find the slope of the tangent line, so I'm going to find the derivative. So I'm going to change colors to show that I'm finding the derivative of f of x. And we haven't talked about this yet, and it's coming up later in the section, but this is where they put the problem in the book, so I just kind of went with them. Is if I'm finding a derivative of more than one term, see I'm adding 3 things here, so I have 3 different terms, I'm going to find the derivative of each one of those terms separately, and then I'm going to add them together. So let's do that. The derivative of x squared would be 2x. The derivative of 3x, remember that n is understood to be 1, so this would be 3. And I guess I could reduce it by 1 and make this 0. I could. And then the derivative of negative 4 is a constant, so that would be 0. So when I write my derivative, that's just simply going to be 2x plus 3, because anything raised to 0 powers 1. I want to find the slope when x is equal to 3, so I'm going to substitute in 3. And when I do that, I end up with 9. So my slope is 9. So the derivative gives me the slope. It's equal to 9. And when I substitute that 3 into the original equation, it gives me the point. Now, I'm a point slope person, so I'm going to use point slope. And I'm going to say y minus the y coordinate is equal to my slope, which is 9, times x minus the x coordinate. And when I simplify that, I'm going to get y minus 14 is equal to 9x minus 27. Oopsie, that's 27. So y is equal to 9x minus 13. And that is the equation of my tangent line. Okay, the next theorem is called the constant multiple rule. And what it says is if you have a constant times a function, what you can do is just multiply the constant times the derivative of the function. So let's start with a here. I'm going to think of y is equal to 5 over x. I can think of that as 5 times 1 over x. So when I do, which I probably would think of that as 5 times x to the negative 1 power. That would be the easiest way for me to use the power rule that I just learned. So to find the derivative of this, I'm going to bring that 5 out in front, and I'm going to multiply it by the derivative of x to the negative 1. To find the derivative, take negative 1, bring that n out front, x, and then negative 1 minus 1, reduce that power by 1. So I have -1 x to -2. That is the derivative, and I'm going to highlight that somehow, maybe. There we go. This is the derivative of that. And that 5 is just sort of riding along on the outside. And now what I'm going to do is I am going to clean it up. So to find the derivative, you can stop moving now. Oh my, look how thick that is. Gosh, that's a mess. So I'm going to do the 5 times the -1 will be -5 x to the -2. No negative exponents, so the derivative of y is going to be -5 over x squared. So now I'm going to do b. I'm going to think of it the same way. I'm going to have this 3 out in front. This x, since it's raised, it's taken the square root, it's understood to be raised to the 1/2 power. Now when I go to find the derivative, the 3 is hanging out on the outside. Then I take 1/2 out in front, x, then 1/2 reduce minus 1 would be -1/2. So when I multiply, I'm going to have 3 halves x to the -1/2, which I am going to rewrite as 3 maybe over 2, and then I can either do x to the 1/2 or write the square root of x. That does not matter. And then I forgot to write my notation. It's the derivative of f of x. Okay, looking at C. C looks complicated, really not that complicated. So this 6/5 is going to be what I'm multiplying by. So I'm going to say y is equal to a -6/5. I'm just going to bring that out in front. And then I'm going to rewrite this as x. And then that would be the 3/4 power. And since it's in the denominator, I'm going to make it the -3/4 power. So when I go to find the derivative, here's a -6/5 that I had out in front. I'm going to multiply by -3/4. And then I'm going to reduce the power by 1. Whoopsie, that's the times sign. And so this will be x. And then when I do reduce the power by 1, it's going to be -7/4. So now when I multiply, the negative times the negative will be a positive. So end up with 6/10. No, I don't want to do that. Yeah. 18/20, positive, yes. And this will be x to -7/4. And so my final answer, I'm going to put that fraction lowest terms while I'm here. So I'm going to do 9 over 10 x to the 7/4. You can leave it as 7/4, or you can put it back in radical form. Either one's okay, as long as your exponent is positive. So give me a second. Okay, the next couple problems ask you to use parentheses when differentiating. We've already been doing that, but I'm just going to make it more explicit what I'm doing. So what I'm going to do is the first one I have y is equal to 3/5 x squared. So before I try and take the derivative, I'm going to rewrite that problem. I see that I do have a coefficient out in front, so I'm going to want to make sure that I factor that out, and that's what they mean by using the parentheses. So I am going to factor out, I'm just going to rewrite this first, so it's still going to be y, because I'm not taking the derivative, I'm just rewriting it. This 3/5 I'm going to factor out, so I'm using parentheses to factor out that 3/5. And then I'm left with That would be 3/5 times, I guess you could say 1 over x squared. Put parentheses around that. I'm going to rewrite that 1 over x squared as y to the negative second. So this will be 3/5. And then this will be x to the negative second. And now I'm going to take the derivative. When I take the derivative, the 3/5 is not going to change. It's going to stay the same. And then I'm going to take -2 out in front and reduce this by 1, so that'll be -3. Now I'm going to go ahead and multiply the -2 times the 3/5. So I'm going to have y is equal to a -6/5, x to the -3rd. And then to rewrite that without an exponent, I'm going to write -6/5. And then this will be over x to the 3rd. And then this is the derivative. So I should have had that notation for a derivative. And that's my final answer. Okay, doing the next one. When I look at this one, be careful that you simplify as much as you can first. I have this 3x squared all raised to the 5th power. I'm going to have to take care of that exponent first before I can even think about taking the derivative. So when I do that, I'm going to have 7. Remember, this 5th power is being raised to the 3 and the x squared, so this will be 243. And then this will be x to the 10th, because when I raise a power to a power, I multiply. This 7 over 243 is what I'm going to put in parentheses and bring that out in front. And then this will be times x to the -10th. Now I'm going to take the derivative. The 7 over 243 does not change. And then I'm going to bring the -10 down in front. And then reduce the power by 1, so this will be to the -11th power. Now I'm going to sort of clean up what I have. So my derivative of t would equal -70 over 243 x to the 11th power. Okay, see, when I'm looking at that, I have the x raised to the -2 power, which means it should really go up on top or in the numerator. So I'm going to rewrite this as 8/5 because that's what I have. That's my coefficient. And then this will be x squared. So now when I go to take the derivative, that 8/5 stays unchanged. I'm bringing that 2 down in front and reducing the power by 1. So 2 minus 1 would be 1. So my final answer for my derivative would be 16x over 5, or you can write it as 16/5 x. Either one of those is the same, and either one of those is fine. Okay, moving on to the next one. This one is the sum and difference formulas. We've already talked about those. So when you have terms, in other words, something that's separated by a plus or minus sign, you're going to take a derivative by a derivative by a derivative, and then you're going to either add or subtract them together. So it's like you take it in pieces, if you want to think of it that way. So when I do the first one, I am going to think of this as, so I'm going to take the derivative of x to the 4th, which would just be 4x to the 3rd. Separated by that minus sign, the derivative of -3x will just be -3. And then that derivative of 7, that is a constant, so that would just be 0. You could write plus 0, but most people don't. So I am going to have 4x to the 3rd minus 3. Doing the next one, again, going piece by piece. I'm doing the notation for derivative. The derivative of 3x squared will be 6x. The derivative of this is understood to be 1, so 1 times 10, this will be 10, and then reduce it by 1, x to 0, and minus 0. So when you write that, you're just going to end up with 6x plus 10. And the last one, using that parenthesis rule we just talked about, I am going to first think of this as, I'm not going to take the derivative yet, I'm going to think of this as a -1/2. That's what I'm bringing out in front, x to the 3rd. Then plus 5x minus 1. So when I take the derivative of the first term, that's going to be 3 times -1/2, so -3/2. Reduce that power by 1, so that'll be x squared plus 5. And you could write x to the 0 minus 0. Your final derivative is just going to be negative 3/2 x squared plus 5. So again, if you separate by a plus or minus sign, you're going to take the derivative of each term and then either add or subtract. Very simple. Example number 7, sine and cosine. The derivative of sine is the cosine. The derivative of sine is, let me say that again. Derivative of sine is cosine. The derivative of the cosine is the opposite of the sine or negative sign. I don't know what you need to do. Well, you need to memorize these. And yes, I know you're sitting at home with your notes, but you need to know those next year. So I suggest you memorize them. They're really not that hard. In fact, on your note sheet, I have those nice graphs that explain why that is. So we're just going to do these. So when I do the next problem, again, I'm going to use the property that I just talked about, and I'm going to separate chunk by chunk. And I am going to, or term by term, I should say. So when I find the derivative of 2, well, 2 is a constant. So the derivative of 2 will just be 0. And then the derivative of sine of x is just cosine of x. So this final answer is just going to be the cosine of x. When I do this one, I have 4 times the cosine of x. Remember, we're thinking of that as 4 times cosine of x. And remember, this is one term. That's why the 4 is pulled out in front. It's not like I don't take the derivative of constant and the derivative of cosine because it's one term. I have to take them together. When I take the derivative, that 4 stays unchanged. The derivative of cosine is negative sine x. And when I multiply those, the derivative is going to be negative 4 times the sine of x. And the last one, the derivative of sine of x is going to be cosine of x, and the derivative of x will just be 1. So my final answer is cosine x minus 1. Not that hard. Again, you do need to memorize those. Number 9 is kind of an application problem, and that's what the rest of the section is. Find k such that the line is tangent to the graph of the function. So what that's saying is I have this constant, and because k is a constant, I have this constant that when I put in the right constant, this line will be tangent to this function. So the first thing, remember, in order for a line to be tangent, it has to have the same slope as the derivative at that point, and it has to have a point in common. So the first thing I'm going to do is I'm going to find the derivative of this function. Remember, k is a constant, so the derivative would be 0 minus 2x. So the derivative is just going to be negative 2x. That's equal to the slope of the tangent line. Well, they're saying that this is the tangent line, and this slope is negative 4. So they're saying negative 2x is equal to negative 4. So they're saying x is equal to 2. Okay, so now I know that x is equal to 2. So now I'm going to have to find the point that has both of these in common. So if they have a point in common, that means that this is equal to y, right? And this is equal to y, which means that if they're meeting at a point, they should be equal to each other. So I'm going to say k minus x squared should equal negative 4x plus 7. We just said x was 2, so I'm going to substitute that in and solve for k. So when I do that, I'm going to have k minus 4 is equal to negative 8 plus 7. So k minus 4 is equal to negative 1. So k is equal to positive 3. So this function should have been 3 minus x squared. I think it's just one k, so you probably could have stopped there, but I like to have closure. All right, and the next one, I think we have somebody. Oh, this is not on your note sheet. That's okay. I just want to talk you through this. This is a position function. This is, if you've taken physics, which I don't think any of you have taken physics yet. My seniors have. If you've taken physics, this is a position. So this S of t stands for the height of the object at a certain time, where t is your time. Based on this coefficient, it's going to be in seconds. the rate, your distance is equal to rate times time. So this, if I take the derivative, that would be the change in s for the related change in time, which would be the slope of the tangent line, by the way. That will give me my velocity. So they're just saying, all this is saying is that your velocity is the derivative of your tangent function, of your position function. So your velocity is a derivative of your position function. Okay, I said that right the second time. All right, so when I go to do this one, I have a diver who's jumping off a board that's 32 feet high. It tells me that his position function is negative 16t squared plus 16t plus 32. It says, when does the diver hit the water? So I want to know if the diver is hitting the water, remember this is my height. So A, when does the diver hit the water? That means that the S of t would be equal to 0 because your height would be 0. If you're hitting the water, you're at the ground. So I'm going to set this equal to 0 and I'm going to solve. I'm going to factor out a negative 16 because that makes my life easier. And I'm actually going to product sum. I wonder how many of you are actually product summing. So I'm going to have t minus 2, t plus 1 when I factor that. So I get t to equal positive 2 or t to equal negative 1. And remember, this is seconds. So in 2 seconds, he's going to hit the ground, which would be this point here. He's coming down here. That would be 2 seconds. And then negative 1 means that if I were to continue this parabola, that would be negative time over here. So we're disregarding that one. So in 2 seconds, he's going to hit the ground. The second part of the question says, what is the diver's velocity at impact? So I need to find the velocity, which means I need to find the first derivative of this. I don't know why it's not changing colors, but I'll deal with that later. So oh, it did change colors. Finding the first derivative. So I'm going to do 2 times negative 16. This will be negative 32t. And then plus 16. That's my derivative. I want to find the velocity when I hit the ground. So that's going to be at 2 seconds. So I'm going to put in 2 here. 32 times 2 plus 16. And when I do that, I end up with negative 48. And you're so trained in math to think, wait, negative, can I have a negative number? And the answer is yes, because this is your rate of change, which means this negative means that you're going down, which the diver is going down. Gravity makes him go down. So that means he's going 48 feet per second. The negative means that he's falling. He's going down. So his velocity is negative 48 feet per second. And the last one wants to know, show that the graph of the function does not have a horizontal tangent line. Well, if I were to have a horizontal tangent line on a graph, well, let's go back to the last one. There's one place where I have a horizontal tangent line, and that's going to be right up here, where I hit the vertex of that parabola. That's going to be a horizontal tangent line. And if I have a horizontal line, then I know the slope of that line is going to be 0. So going back to this one, I am going to find the derivative. Whoopsie, wrong way. I'm going to find the derivative, and then once I find that derivative, I'm going to set it equal to 0 to find any horizontal tangent lines. So the derivative of 2x will just be 2. The derivative of cosine is negative sine. And then the derivative of 3 is 0. Plus 0 minus 0 doesn't really matter. Remember, the horizontal tangent line means that the derivative is going to equal 0. So I'm going to put 0 in here. And then I'm going to solve for x. So I'm going to add sine of x to both sides. The sine of x is equal to 2. And if you remember anything from trig, you should remember that your sign fluctuates between negative 1 and positive 1. It can never equal 2. So this is not possible. And since that is not possible, that means you have no horizontal tangent lines. Boy, that that got messy. All right, well, I hope this video helps, and I will see you soon.